Hi, and welcome to another episode of Spiral Physics Education. In this episode, we're going to be looking at kinetic energy store. But before we go into that, a few things that you need to know to help you get the most out of this episode will be having an idea again about stores and transfers and examples of stores and transfers, the principle of conservation of energy, because everything must obey that principle, and also that work is done when energy is transferred between different stores. So getting on to what's going to be covered in this episode, we're going to be obviously looking at kinetic energy. We're going to be using this equation to look at different examples of calculating kinetic energy. And we're also going to be linking kinetic energy to the term work done. So let's get straight into it and what kinetic energy is. So an object in motion will have kinetic energy store, and if an object increased its speed or velocity, its kinetic energy store would increase. So that's what we're going to be looking at in this episode. And we can calculate the kinetic energy store of an object by using this equation, which looks quite complicated on the surface, but it's very, very straightforward if you follow some simple rules. So EK stands for kinetic energy, so kinetic energy is equal to half times mass times velocity squared. So it's a little bit wordy in this form, so we rewrite it as a half mv squared. But do be careful, because I've seen students put the square in the wrong place, so that it's a half mv brackets all squared. That's wrong. Remember that it's just the v that is squared. And we have to be a little bit careful of the units. For kinetic energy to be measured in joules, mass must be in kilograms, and the velocity must be in meters per second. So let's have a look at an example to start off with. Let's look at quite a simple one of a cyclist moving at 5 meters per second, and it has a mass of 100 kilograms. So if we look at the units straight away, we can see that the units are absolutely fine. The mass is in kilograms, and the velocity is in meters per second. So we don't need to worry about the units. So the first thing that we do, we write the equation down. In an exam, that could be worth a mark. Then substitute in the values. Now this is where substituting the values in has a massive advantage, because it reminds you that it is just the 5 that is squared. So rather than trying to do all of the calculation on your calculator and not writing any of it down, try to get used to showing each stage of your calculation on the paper. Remember to communicate what you're doing mathematically with the person that's going to read it. So I'm showing the next stage there. 5 squared is 25, showing exactly what's happening mathematically during this equation. And then I can put that into the calculator, and then I can show you that we've got a value that's quite big, but if I use standard form, 12.5 times 10 to the 3 joules. Once again, you don't need to use standard form, but it is a good idea if you're hoping to get grades 7, 8 or 9 in your exams, to be confident at using standard form. So in a second example, a little bit harder still, so we're going to look at a tennis player serving a 50-gram ball going from 0 meters per second to 25 meters per second. What makes this one a little bit different is it doesn't specifically say calculate the kinetic energy, it says calculate the work done on the ball by the tennis player. So here we need to be very confident with the term work done. So anytime you hear work done, that means there's a change in energy that's taken place. And specifically here, that change in energy has been an increase in kinetic energy store. So really what this question is asking is, what's the increase in kinetic energy of the ball? So another thing that we need to be careful of is the units. So doing a mental check just before we go straight into doing any calculations, that mental check shows us that we've got 50 grams. So we need to be very, very careful and wondering whether that's an appropriate unit to use in this equation, which of course it isn't. So we write our equation down, and we substitute in, and you can see that converted 50 grams into kilograms just by dividing 50 by 1,000. Notice that it's the 25 that is just squared. And the next line, the next thing that we do mathematically is just square the 25, so we get 625. And at that point, we're ready to plug everything into our calculator, and we get just over 15 joules. And I'm going to finish that off by representing that answer to 3 significant figures, because if we look at the numbers in the question, all of the values supplied are to 3 significant figures. So really, again, if you're thinking of you want to aim for being a grade 8, grade 9 student considering doing A-level, then that's the next level up that you should be thinking of. How many significant figures do I write my answer to? 15.625 is still fine. You still get the marks in the exam. However, 15.6 to 3 significant figures is a much better answer. And don't forget the units, joules. Okay, moving on to a harder example still. Here we've got quite a heavy train with a certain amount of kinetic energy store, and this time we're being asked to calculate the velocity. So it's a very, very different question. It's still about kinetic energy, but we've been given the kinetic energy, and we've got to calculate the velocity. So what that means, our equation that we're going to use is still the same equation, but it means we've got to rearrange that equation, which can look a little bit complicated. I'm going to take you through step by step how to rearrange this equation so that you can get V equals from it. So I'm going to show you a different formation of it, which is still correct. Instead of having a half mv squared, we're going to have mv squared all over 2. Now I'm trying to get V on its own, so I'm going to show you step by step what to do. So that 2 is being divided at the moment. And what I'm going to do, I'm going to bring it across to the other side of the equals sign. And as it's being divided at the moment, when it goes across to the other side, it becomes a multiplying number. So we get 2ek equals mv squared. And now I'm going to, in the next step, trying to get v squared on its own. So if we look at mv squared, I'm going to try and get the m over. And it's being multiplied at the moment. So if it goes over to the other side, it becomes a divide. So we would get 2ek over m equals v squared. And then if I square root both sides, I can get v equals the square root of 2ek over m. So that's quite a tricky process involving probably one of the hardest equations at GCSE or IGCSE physics. So if you're thinking of trying to aim for a grade 8 or a grade 9, do practice trying to rearrange that equation so you can get the equation v equals square root of 2ek over m. Now this is the equation that we can use to calculate the velocity. So now we can check the units. Now in this one, the units are a bit strange. So we've got 72.6 mj. So that capital M means mega. It means times 10 to the 6, it's million. So when we're writing that out, 72.6 times 10 to the 6 is the same as 72.6 megajoules. So we've got to make sure we're writing joules in our equation. And rather than do everything in one go, work out what that value is before we square root it. So we've got 121, which is a nice number to square root, which gives us 11 meters per second. So I hope you found that useful and looking into kinetic energy. And do subscribe to the channel, have a look at some other videos that hopefully will help you improve your physics and hopefully your grades too. See you next time.